Alright, welcome back. Good morning, I should say. What I want to look at today is something called ribbon microphone transducers. So what I intend to do is to look at various types of transducers. So make sure that you read the information as it is presented, that you write up the information for yourselves, and that you do additional research into the various types of transducers that I have given. Now remember, I've only given you a sample of transducers. There are many other types of transducers, but it is in your interest to become familiar with these, especially if you're going to move into the area of being an electrician or even an electronics engineer. Okay, so firstly, ribbon microphone transducers. Whenever a wire or a conductor is moved in a magnetic field, a current is set up in that conductor. This is the basic principle of the moving coil microphone. Okay? Now, the ribbon microphone works on the same principle, but in this case, there is no diaphragm as such. Now, most microphones have a diaphragm that moves within a magnetic field, but in this case, there isn't one. What it has instead is called a corrugated ribbon. Okay? But instead, a corrugated ribbon of aluminium alloy is suspended in a strong magnetic field in such a way that it can be moved through and through by the sound waves striking it. Okay? The through and through motion of the ribbon sets up a flowing current which moves in sequence with the ribbon. The strength of the current will depend on the strength of the waves hitting the diaphragm. This in turn will depend on the speaker's voice. Now I noticed, yes, I've referred to the corrugated ribbon as a diaphragm, but as we have said before, it is more of a corrugated ribbon than a diaphragm, as that diaphragm tends to be fixed more in one place than another. Okay. Or you can say that the ribbon replaces the diaphragm. And here I've given you an example as to what one of these would look like in reality. And this is what, well, you see them in the BBC, CBS, etc. Okay. And here I've simply drawn a diagram of the ribbon microphone for yourselves. You can see that here the corrugated aluminium foil set up in a magnetic field. But to make sure that we understand this a little bit more, I've gone on further and give you a example. Now read the information above in full so as to have a good understanding, okay, and do some additional research of your own as well. You can never have too much knowledge. So here, this here is simply this down here now, okay. So I've tried to get a better picture of it so you can see it. That is that here, okay. You can see that. Let me just pull back a little bit so we can get it all in. Okay, pan out. Okay, you can see here step-up transformer basically. Okay, because the generated sound here would be amplified. Okay, corrugated ribbon element, and this is referred to as the ribbon microphone, simply front view. Okay, magnet structure. Okay, so it is moving within a magnetic field. Now, ribbon microphones are the most sensitive with quality acoustics. Okay, simply meaning that they are they reproduce a quality sound. Excuse me. Now, transducers. Transducers are devices which are used for bringing about a change in some physical condition, like temperature or pressure, into an electrical signal that can be used to indicate a display or operate some other device. Transducers are passive devices requiring no external circuit or power supply. A record player contains a transducer that converts mechanical energy to electrical energy. Now, the mechanical energy comes from the needle moving in the grooves of this record. A microphone is a transducer. A loudspeaker is a transducer. Okay. Now, remember, all I'm doing here is providing you with a little bit of information. To go into more depth, you'll need to do some additional research of your own. So bear that in mind. It's purely to provide you with some additional information that you can use for yourselves. Loudspeaker as a transducer. The moving coil loudspeaker is used to reproduce sound energy from electrical energy. It has a coil which is called a speech coil wound on a cylindrical former, which is positioned symmetrically centered in the radial field of a pot magnet. If you've ever dismantled a speaker, you'll see that it actually forms a pot magnet, and you can see the coils wrapped around the cone of the speaker that moves within that magnet. Thermocouple is a transducer. Okay, and again, here we have a thermocouple. Tail end and junction end. That's where the two opposite pieces of metal meet. So you have T2, which should be greater than T1. Okay, voltage being applied there. Once it gets to a generated voltage is applied, which determines or helps you to set your temperature. Now, thermocouples. The operating principle. A thermocouple is a device made by two different wires joined at one end, called junction end or measuring end. The two wires are called thermo elements or legs of the thermocouple. The two thermocouples, thermo elements, are distinguished as positive and negative ones. The other end of the thermocouple is called tail end or reference end, figure 1. Now, figure 1 is the figure we just looked at above. Okay. Excuse me. Now, the junction end is immersed in the environment whose temperature T2 has to be measured, which can be, for instance, the temperature of a furnace at about 500 degrees Celsius, while the tail end is held at a different temperature, T1. Example, at ambient temperature. That would mean room temperature. Okay. So let's go back to what we're looking at, and again we're looking at T2. Let me just go back a little bit, and here you have T1 and T2. Okay. Now, you can expand on this further if you like by doing some additional research, and it goes into more depth. But all I want to do here is purely as an introduction. Piezoelectric crystal. piezoelectric crystal. Now circuit symbol, and we normally call this, can refer to this as a quartz crystal. The piezoelectric transducer is a device that converts electricity into mechanical forces or vibration. Although the piezoelectric transducers have other uses, such as their use in ultrasonics, piezoelectric transducers usually converts electricity into vibrations and vibrations into electricity. With this piezoelectric crystal, it vibrates constantly. Oh, there's a little line missing here. So let me just see if I can put that back into place. Ah, okay. Undo. Sorry about this. Okay, just let me go down a little bit. Okay, as I've expanded it, made it larger, I've lost a little bit of data. Okay, so let me just see if I can put that back into place. Bear with me for a moment. Okay. Well, at least here we're making sure that you have all the information anyway, and we haven't missed anything out due to my talking or drifting. There we are. There's my line for my piezo crystal. Okay. Now I don't think I'm going to get it down there, man. Let me just see. 1 second, wait me for a moment. Did it. Okay, let's see if it has done it. Yes, okay. And that's the circuit symbol for your piezo crystal. Okay, when I made it larger, it took it out of focus. Okay, good. That's your circuit symbol. Now, a piezoelectric crystal vibrates constantly, and you'll find that they're used in watches as well because they tend to generate a constant frequency. Okay. Now you can read it for yourself. I'm going to read that out again. Okay, they rely on two phenomena known as electrostriction. The piezoelectric crystal too vibrates, bringing about a change of state, and the piezoelectric effect. Okay. Now you can read more on the piezoelectric crystal. There's quite a lot in it. Okay, because it's used for many things. How piezoelectric transducers works. Piezoelectric transducers are made of both positive and negative elements that align themselves when in the presence of an electric field. This property causes them to actually change dimensions. When an alternating electric field is applied to the transducer, the material vibrates back and forth and produces an ultrasonic frequency. While most piezoelectric materials move back and forth between states, some are locked into their position and simply produce an electric current when a mechanical force is applied. Originally made from quartz crystal, Russian salt, but now made also from ceramics. Okay. And I think that's it for now. Okay, thank you. I hope you found this useful, etc. But don't forget, again, write out the information for yourselves. Do some additional research. There's a lot of work on this, on these items of transducers. You will be dealing with transducers in one form or another, whether you're an electrician or whether you're in electronics. They're vital. You can never have too much knowledge. Okay, let's just go back up a little bit and make sure that we have everything in. Okay. Okay, I think we're good. And okay, very good. Thank you. Right, have a good day and thank you for your time, and I hope you found this useful. Bye bye.